Alright, hey guys, welcome to another episode of Learn with Anirudh. Now, this is the fifth episode of the five-part series where we have been taking a look at all of these fantastic sorting algorithms in Python. Now, I know that a lot of you all tend to pull your hairs out when it comes to working with these sorting algorithms, so I went here and pulled my hairs out, finding the best and the most simple ways to explain how these work for you guys. Now, here on this episode, we're going to take a look at an amazing algorithm which is quicksort. So, what are we waiting for? Let's get started. Alright guys, so as I just mentioned in the introduction, we've already had a chance to take a look at four other algorithms. Bubble sort is done, insertion sort is done, selection sort is done, and even an algorithm as complex as merge sort was completely done. Now all four of these episodes, the links to these episodes are present in the description box below. If you haven't had a chance to take a look at them, do take a look at them, because including this episode and all of those, we've had multiple relatable real life examples, explanation of how the algorithm works, step by step solution of examples, working through the theory, understanding why the algorithm does the things that they do, and eventually also showing you how elegant and simple the Python code is. So if you haven't had a chance to take a look at that, I highly suggest you take a look at them, learn them, and then come and tune into this episode, because in this episode we're going to be taking a look at apparently the most complex sorting algorithm that it is very difficult for you guys as freshers and beginners, which is quicksort. As always, if there's anything that's very complex for you guys, I'm here to simplify it down for you, and quicksort is a fantastic algorithm. I absolutely love it, and by the end of this episode I promise you that you're gonna love it as well. So if you haven't had a chance to subscribe to the channel yet, do take a second to hit the subscribe button, because by the end of this episode you guys are going to become experts in quicksort. Well, one important thing, if you guys have watched the TV show Friends, of course, a very popular TV show, there's an episode in season 5 where Ross keeps saying pivot, pivot, pivot. Now, unfortunately, I'm gonna have to become Ross for this particular episode, because I'm gonna be saying the term pivot a lot. So stay with me, and I know a lot of you all might be laughing throughout the episode every time I say pivot, but the word, the term, and the concept pivot is a very, very crucial part of this particular episode. So brace yourselves, because there's going to be a lot of pivot that's going to be happening right now. Okay, enough of that. Let's get started with an example that you can relate to. Now, here's a case where you might have actually used quicksort in your real life. Let's just say that you have planned a vacation, maybe you and your girlfriend, you and your boyfriend, whatever it is, or you and your family too. You've planned a vacation and you're headed out to the mountains, to the beach, or whatever it is. And of course, what's the first thing you do after you book all your tickets? You go shopping. Now, when you go shopping, there might have been a lot of things that you'll have to buy. So you usually prioritize, right? You might want some sweaters, you might want some mint, sunglasses, water, food, soap, everything, all the basic requirements, correct? Now, it is good that you want all of these, but there's a very good chance, even if you're just casually shopping with your mom, there's a good chance she'll say, hey, even if you forget sunglasses, do not forget soap. Even if you forget soap, do not forget food. So there is a priority to what you're supposed to buy and how important it is at first that you have to get it. So it's very simply that we can assume that there is a certain priority to our shopping list here as well. For example, food has to be the number one priority. Of course, I bet a lot of you all never travel without having a good amount of food. At least I don't. And food has to be P1. So the lower the number, the higher the priority. P1 means it's the first priority, P2 is second priority, and P6 is the last priority. All right. So food becomes first priority, mints is second priority, water is the third priority, sweater is 4, what else? Soap is 5, and sunglasses are 6. Alright. Now stick with me on this for a second, because this is where we're going to start working through the pivot word. So what we're going to have to do to solve this using quicksort is, so basically our answer has to be 1, 2, 3, 4, 5, 6. Right now it is 4, 2, 6, 3, 1, 5. Correct? It is not in the order. Just take a look at this. This is not in the order. Now, to use quicksort to sort this, it is very simple. We need something called as a pivot element. A pivot element is basically an element that you pick either at the start of the array, the end of the array, the middle of the array. You can pick it up randomly. In this case, let's just say that the sweater is the pivot element. Now, why do we require a pivot element? Is because we're going to use this element to actually go on to split our array into two different different parts. Now, quicksort works using an approach called as the divide and conquer algorithm. It is very, very simple and very similar to actually how merge sort also divided the algorithm. If you haven't had a chance to look at that, that was episode number 4 in this list, so make sure you check that out as well. So here again, we're going to be using the pivot to basically split the list into two parts, split the array into two parts. All right. So one important thing that you have to do is that our pivot element was P4. Let me just go back, right? It is P4. Now P4, if we have to split the array, where do you think P4 has to be there? So before P4, there has to be 3 elements, P1, P2 and P3, correct? So all I'm going to do is I'm going to rearrange the list in such a way that our pivot element is in the correct order. All the more priority items will go before the pivot, all the lesser priority items go below that. Just take a look at this right now. We change the entire order where everything above the pivot element are all less than P4. Correct? So similarly, what happens is that all the elements after the pivot are all bigger than P4. Now you can assume that even if we did split this array into two parts, we can sort all of them out correctly. Don't you think so? So the pivot element is not only very important for the logic of quicksort to work, but for Python to also understand where to split the array, how to split the array, what logic to use, and eventually using that logic, it just simplifies the entire approach. And you might have heard about this, and in fact you're seeing it right now. This is called quicksort for a reason. It's a very, very efficient algorithm, and you're going to see why it is so efficient compared to something like bubble sort, selection sort, or insertion sort. Right? So all we did until now is we made sure we picked a pivot element. We made sure to put the pivot element in a place where we have all the elements lesser than that to the left side, or in this case above, and all the elements which are greater than that to the right side, or in this case below that. So what do we do next? What we do next is very simple. I'm going to tell you, all we have to do is we have to group it into two parts and start sorting there. You can see that mints, water and food have the priority 2, 3 and 1. Now you know that if we have to sort this in the correct order, the answer is going to be 1, 2 and 3, P1, P2 and P3. Correct? So all we're going to do is we're going to sort it in such a way that all the elements before the pivot element is sorted. Right now, take a look at it. Don't you think it is sorted 1, 2 and 3? So the left side of our pivot element is completely sorted. Of course, you already guessed what we are going to do next. What we are going to do next basically is to sort out everything after the pivot, the second part of the array where we have split the array. It says P6 and P5. Of course, we know that P6 and P5 is not in the correct order. We have to make a very simple swap there, which makes it P5 and P6. And right now, even though we had spreader as the P4 element, just take a look at it from the top till the bottom. After we have sorted the group based on our pivot element, our entire array right now is sorted. Now, if you watch the first episode where we discussed bubble sort, we had to make a million comparisons. Every element had to be compared to the element very next to it, to the adjacent element, and that in turn will take up a lot of efficiency. Even though your computer can do all of this in a couple of microseconds, it still is not as efficient as it can be. And quicksort solves this exact problem by ensuring that there is a logic in place where the number of comparisons that are needed to make sure to be certain that there is no element smaller than 1 or there is no element bigger than 1. In this case, bigger than 1 element is there. So it becomes important that you understand at this moment of time that quicksort is an algorithm, as its name itself suggests. It's pretty quick. So what do we do? Are we done with it? Even though we have P1, 2, 3 and 4, 5, 6 all ordered there, take a look at your screen right now. We still don't know. In this particular case, our pivot element was sorted, but we have to do a manual check to see if the pivot is sitting in its correct role. So we ordered all the elements based on the pivot element. Once we realize that pivot is 4, we just realize anything less than 4, throw it to the left side. Anything greater than 4, throw it to the right side. So what if the 4 is not in its correct place? What if 3 and 4 were swapped? What if 4 or 5 was swapped? So in that case, you have to also check. The logic for quicksort says just check if the pivot is also in its correct place or not. And in this case, yes, the pivot is in its correct place, so we can be assured that our entire array was sorted. So what did we do? Step number one, we had to choose a pivot element and we're going to be dividing the array into two pieces or two parts at that particular place. So all the elements that are lesser than the pivot element goes to the left. All the elements that are greater than the pivot go to the right side, and after that we make sure that the pivot itself is in its correct place. Eventually we sort everything on the left, eventually we sort everything on the right. Now we already know that the pivot is in its correct place. So if the left is sorted, the right part of it is sorted, and the pivot is sorted, of course, at the end of the day, it means that your entire array is sorted. Now, this was a real world example of how you might be doing quicksort in your head in that moment while you're shopping for your vacation. I bet you're wondering, saying, oh, I wasn't doing any sort of quicksort. I had to quickly go and shop. You might be right, but check this out. In this particular example that we're going to take a look at, we have a couple of numbers and a beautiful looking array which consists of 7 elements, and we're going to be using quicksort, and we're going to go step by step to understand what it is exactly as per the logic, as per the algorithm, and how we are going to sort this. It is very simple, so make sure to pay attention from here on. You're going to be following through all the steps and I'm going to be guiding you through what exactly happens all the way. Alright, now the first important step that we did not discuss previously is to check if we have more than one element in our array. Now, okay, in our current example, we have 7 elements. It is fine. We can look at it and we can say, hey, we have more than one element. What is the fuss all about? But what if you had only one element? This is the reason we have to check. Now, how do you sort this? This is already sorted, correct? You have nothing to compare it with. That means that it is a default assumption that it is already sorted. You know this, but your algorithm will fail. If you do not tell Python that, hey, if it is only one element, consider it to be sorted, Python will get very confused, and there's a very good chance in one or two cases it might fail because it doesn't understand. It's like, okay, so where are the other elements? No, even if there's only one element, consider it to be sorted all the time. If there are more than one element, that is when you have a chance to compare it with something. That is when you have to use the logic to sort, correct? Now, let's just get back to understand that. As I just told you, this one is already sorted because we had one element. Now, let's get back to our original array. Our original array is still looking messed up. If you want to pause the episode right now, just open up a pen and paper and just sort this out manually. I bet it's going to take you less than 5 or 10 seconds to start writing elements down, sorting it and putting it in its correct place. Now, once you have done that, I'm going to tell you what is going to happen as per logic. As I told you, we're going to be saying pivot a lot. In this example, I'm going to be saying it more. So in this particular case, what we're going to be doing is we have to pick one of these elements as pivot, and I have picked up the element 7 as pivot. Now you might be asking a question saying, hey, there's 1, 8, 3, 9, 4, 5. Why did you have to go on to pick 7? What is so special about 7? Now, you can actually go on to perform quicksort in multiple logics basically. One logic you can use to actually have where the pivot element, you pick it at the first, where you pick it at the last. You can pick up the middle element as the pivot element, or you can also have a logic where you can pick up the pivot element randomly. So if you're ever asked in an interview saying, how do you pick up the element? Just ask the interviewer saying, how do you want to pick up the pivot element? Because you can do it in multiple different ways. In this particular case, the Python program that I'm going to be showing you, we have picked up the pivot element to be the last. The logic is based on that. So I want to take you through the exact logic. If I show you something else here and the code is doing something else, I bet you're going to be confused. And again, if there's anything confusing, we don't allow that here, because at the end of every single episode of Learn with Anirudh, I want to make sure that all of your confusions are cleared. So I hope you understood why we picked up 7, our last element, as the pivot element. All right. Okay, now we know that we have 7 to be our pivot element, and just go back to that shopping example. What did we do when we started understanding our pivot element in that particular case? We had to make comparisons to understand if we have all the elements that are left of that pivot in the correct places. Now just check in this case if the element 1 is less than 7. The answer is true. 1 is less than 7. Now in the previous cases, whenever our comparisons was true, we usually made a swap right then and there, correct? Now in this case, we don't have to swap anything. Even though 1 less than 7 is true, all we are trying to say is, hey, 7 is our pivot element. Any element that is smaller than 7 has to be on the left side of 7, even in our final sorted array. Think about it for a second. 1 can never be greater than 7, so 1 can never go to the right of 7. So we don't have to perform any swapping here. This step of checking is where quicksort is more intelligent than all the other algorithms that we have discussed, because it understands at this moment of time saying, don't just wastefully start swapping, because at the end it won't matter. Now, this is a good step, but what's next? As I just told you, one should be on the left side of the pivot all the time, and in this case it's valid logic, so we're not going to change anything. So the iteration variable, we have two loops, right? So it's always the I loop and the j loop. While the I loop is moving through each and every element of our particular array, we use the j loop to perform our comparisons and perform our swapping. So as the I loop moves through each of these elements, we are going to compare each of these elements to another element. So how do we do that? I'll show you to you. Next, we just looked at 1. Now we're going to take a look at 8. Is 8 less than 7? 8 is not less than 7. It is false. So this is understood in any case by common sense as well, saying we do not swap. Correct? Because if 8 was less than 7 is only when we would make a swap. In this case, it is not. So what next then? We try to find the next smallest element in the array. This time, do not compare it with 7, even though we're making a check here to say if 3 is less than 7. 3 is less than 7, correct. That means 3 has to be on the left side of 7, but take a look at 8. As soon as the algorithm looks at 8, it wants to find another element which is less than that current element. So is 3 actually less than 8? Yes, it is. 3 is less than 8. The iteration variable is sitting on 8. It wants to find the element which is immediately less than that to perform a sorting. Well, 8 in this case realized as soon as the I loop was at 8, the j loop was at 3, it realizes that, hey, whoa, so j says to I have an element which is less than yours, let's make a swap. So what do? We swap 3 and 8. Why do we swap 3 and 8? Because as soon as we are moving from the left of the array to the right side, the second we find a smaller element than the element where we are at right now, all we are going to do is we are going to swap them currently. We were at 8, we were looking ahead, we found an element which was less than 8, we just made the swap right in there. Look at that. Now we swapped 8 and 3, so it became 3 and 8. Okay, this is understood. What next? We're done with 3, we're done with 8, we're going to go to the next element, which is 9. Now we're going to check if 9 is less than 7. Well, 9 is not exactly less than 7, so we don't have to make any comparisons. And in this particular case, you have to be a little intelligent here to understand that the second you move to the next element is 4. Now, we just looked at 9. The algorithm there would have told that, hey, you're at 4 right now. There was 9 previously, and in this case, there is another element which is before 9, which is even smaller, right? Our iteration variable is still sitting on 8. Even though we moved ahead in the logic to compare, we are still at this particular area to make our sorting and to make our swapping logic. So as soon as it remembered that there was 8 and now it is seeing 4, it is saying, oh, okay, so there is an element which is less than me right now and I have to swap that. So eventually we swap 4 and 8, and as soon as you swap 4 and 8, things are going to mess up slightly more. Now just follow along very carefully, because we're going to move one more step ahead in our checking array, where we're trying to compare if 5 is less than 7. Yes, 5 is less than 7. You already know that, but 5 is misplaced. 5 is not in the current place right now, because our iteration variable, if you remember last, we swapped the position here. It was at 9. So I is still at 9. Now, as soon as it is at 9 and it sees an element less than 9, it is like, hey, I want to swap this right away. And it realizes that 5 is of course less than 9. And since 5 is less than 9, we basically swap. So ladies and gentlemen, the logic here is very simple. The second your iteration loop moves through and finds an element which is less than that element, swap it immediately. That is all you have to do. It is sort of like a very, very, very efficient way, or basically an intelligent bubble sort is what I can tell you. So 5 and 9 are swapped, and if you're observing very carefully, the array looks more sorted than what it was, correct? But are we done? No, we are not done, because observe the pivot element. What was the critical step that I told you when we were discussing the shopping example? In that particular case, coincidentally, our pivot element was in its correct place. Take a look at this right now. Our pivot element here is not in its correct place. This is not a sorted array that you're looking at. So what do we have to do? We have to make sure that we sort the pivot element since it is in its incorrect position. Now, where do you have to sort? Our iteration variable is still sitting in 8. Now it makes a comparison saying, hey, is 8 less than 7? Well, the answer to that is no. And once you have an answer to that to be no, 8 is not less than 7, it means that it has found an element which is less than 8. So all we're going to do is we're going to compare 7 and 8 and we're going to swap 7 and 8. Now as soon as you swap 7 and 8, fantastic. Observe this very carefully right now. 7 was our pivot element. We swapped the 7, we put it in its correct place. So what does this mean for our array even though it is not sorted? At this moment of time, observe the pivot element and all the elements around the pivot element. So as I just told you, observe the pivot element carefully here, because if you observe its placement, of course the pivot element is already sorted, but what do we do whenever we have the pivot? We split the list into two parts at the pivot element, correct? So let's quickly split it into the left side and the right side part of the array right now. This happens in a function called as the partition function in the Python program that I'm going to show you. But for now, just understand that we had the pivot. We're going to just split everything into two parts and we're going to start sorting the left side and eventually we're going to start sorting the right side. Before we go on to sort the left and the right side, observe all the elements on the left. All the elements on the left are what? They are all less than the pivot element, which is 7. Similarly, all the elements on the right are greater than the pivot element. Now, this is a very, very important step for the algorithm, because if you miss this particular step, the entire quicksort algorithm is going to come crashing down and it is never going to sort the array, because our pivot element in every single point of time, even though in your head you might be laughing at that Friends joke that we discussed at the start of this episode right now, is that all the comparison happens because of the pivot element. Pivot element is like a pillar through which we're going to move around and we're going to support the entire house to be built on. So it is a very important, even though we do not directly compare it for swapping, we compare it to analyze the position of the elements there and eventually make our comparisons and swapping. So all the elements are, all the lesser elements are to the left, all the greater elements are to the right. And now it's time to sort everything that is to the left of the pivot element, right? So what happens now is that 7 is not going to remain as our pivot element forever, because we have come to this short array. When we have come to that short array, you cannot have 7 as the pivot anymore, because 7 is part of the right side array now. So what do? We, as per our Python logic, I told you that we always pick our last element in that array as our pivot element. So we consider this to be an entire example right now, 1, 3, 4 and 5. Just forget 7, 9, 8 for now. Just take a look at everything that's already highlighted. So we're going to say, hey, this is our entire algorithm right now, and just go back to the start of this example. We're going to repeat exactly all the steps to get towards here. So 5 is now the pivot element. We're going to make comparisons to understand if there is any element that has to be sorted before the element 5. In this case, thankfully, everything is coincidentally sorted before 5. So we really don't have to sort anything, and all the elements before 5 are sorted. So what do we do then? We say 5 is in its final place. We consider 4 to be the new pivot element. If 4 is the new pivot element, make comparisons to check if everything is sorted before 4. If it is not sorted, sort it and eventually move on. In this case, it is already sorted, so we don't have to do anything. Okay, that means 4 is also in its final place. What do we do next? We consider 3 to be our pivot element, and eventually we compare 3 and 1. Now we don't have to make any changes there, because even though we have to sort everything as per our logic, in this case everything is already sorted. So 3 is also in its final place, and in that particular case our pivot element is going to be 1, and once your pivot element is 1, there really isn't anything much to do, because at that moment it says that you are at the smallest element in that particular array. So you're sorted. Right now, take a look at the left elements. Even though we started this example out on that particular case to be exactly 1, 3, 4 and 5, as per what the logic is, as per what the algorithm is, this is exactly how that happens. Now done, everything, our entire left array is sorted. Time to move on to the right array. Now the right array is not sorted, correct? It has to be 7, 8 and 9. Right now it is 7, 9 and 8. What is our first step? Now we're going to consider this as an entirely full array example and eventually work on it. So of course 8 has to be the last element, has to be our pivot element. As soon as we have the pivot element, we're going to make small comparisons out there, and eventually once we compare 8 and 9, as soon as the iteration variable starts moving from the left to the right side, it is on 9 right now, and it figures out saying, hey, I am 9, you are 8, you cannot be ahead of me. So we make a simple swap there, and eventually 8 goes to 9's place and 9 goes to 8's place, right? Now what happens? It is not just that we made one single swap here, we also made sure that our new pivot element is in its correct places. So how do we know that it is in its correct place? Take a look at that. Everything to the left of the pivot in that particular array is sorted. 7 is in its correct place. 9 is in its correct place. So yeah, everything to the left of the pivot is sorted, everything to the right of the pivot is sorted. And what does that mean? It means now, as soon as we bring those two array pieces together and make it into one, the array is completely sorted, and so are you at this moment of time. So if you want to take a second to sing the song I'll Be There For You, you can go about singing it, because I'll be there for you wherever you find something as complex or as confusing as this, to simplify it down. And of course, if you did like everything you saw in this example, I would love to have your subscription. Now, we're not done with this. This was just one example that we discussed. What we have to understand is how we went about doing this. Let me give you one more recap of how we did this. First of all, we had to define an element as the pivot element. You already know how we do that. We picked up the last element as our pivot. Once we did it, we had to split the array into two pieces. Once we split it, we had to make sure that the pivot element itself is in its correct place. Once the pivot element is in the correct place, sort every single element to the left of the pivot, sort every element to the right of the pivot, and check if the pivot itself is in its correct place. If all three of these conditions are correct, just merge the arrays back again, and your final array will be completely sorted. We're good for theory. We understood how it works. We understood the algorithmical approach. We understood the real world approach. We understood how to go about sorting it. So right now, it's high time you guys understand why quicksort is even so popular. Let me tell you this, we had 6 items on our shopping list there, be it on the shopping list or on the example, and we literally sorted it out in 3 or 4 steps, correct? Now imagine, instead of 6 elements, if we had 128 elements. So if we had 128 elements, it would have taken us somewhere around 896 iterations to go about sorting it. Now you might be wondering, hey, big deal, I'm never going to show you an example which has 128 elements. You don't have to manually sit and compare it and do it 900 times almost. That's good. Here is where the catch is. If you use selection sort on the same 128 elements, it is almost going to take you to an efficiency of, the worst case efficiency is 128 raised to the power of 2. This is again a concept of time complexity which you might not know at this moment. Do not worry. I'm going to be making an episode where I'm going to explain why this is the case. But just understand that if you have selection sort with 128 elements in it, it is not going to take you 900 iterations like it did in quicksort. Selection sort will have to make 16,000 comparisons. There is a reason quicksort is called quicksort, as I told you at the start of this episode. This is the reason why. Where do you think 800 is and where do you think 16,000 is? Even though your computer can do both of these in a couple of microseconds, it still is the matter of efficiency, correct? So quicksort happens to be extremely quick, extremely popular. Apparently a little bit confusing, but right now I hope you guys are all clear with all of that. But this is the reason you had to understand that. Now theoretically we are all good and done. We understood even why quicksort is popular. It's time to take a look at the Python code to make sure we have a complete understanding about how that works in terms of code as well. So let me quickly open up Google Colab and we can get started. Alright guys, as you can take a look at your screen right now, we have opened up Google Colab. If you want access to the exact same Jupyter notebook, just head to the description box below. This entire Jupyter notebook is right there open for you guys. Just click on the link. It is going to bring you up to the exact same page that I have opened, and all you guys can do is see the exact piece of code, work on it, modify it, and eventually work out your arrays and do it by yourself. Now this is a lengthy program. Let me actually show you guys the entire thing. Look at this. I have to scroll a bit because at this moment of time, compared to something like insertion sort, this seems like the logic is extremely big. But once you manually understood how the algorithm works, this is a piece of cake. I'll explain. The first step should already be clear to all of you all. What are we doing? We're just finding out the input array. Without the input, there cannot be any output. So in this case, we're going to just take the same shopping example. 426315 was our priority example. That's what we're going to give as the input. And then eventually we have a message to basically print us the input message and eventually find out all the logic. Now the logic here is divided into two functions. One is called as the partition function and the other function is called as the quicksort function. Now what are we going to do with terms of two functions here is the first function, right? I'm going to select all of these elements right now. Look at this. This is basically the partition function. This function is going to give us the logic. It's going to say where to split the array, and it is going to help us make this comparison to say if you find an element that is greater. You imagine the logic where you are actually swapping the elements, where I told you you're currently performing an iteration. If you find an element bigger than that, swap it immediately. This function is going to help us do exactly that. I'm just going to guide you through how it entirely works. So basically, first and last is going to be our index positions of the array, not the elements of the array, the index position of the array. So while we have first less than last, we make this check because we need to find out if we have only one single element in the array. In this case, we have multiple examples. We know that, Python doesn't know that, so we have to make sure to have this logic. Now, while first is less than the length of input array and our input of array of our first element is less than pivot, this line is basically telling until you find an element greater than the pivot element, keep incrementing, keep moving to the next element. And once you do, just make sure that you move the left index a little bit higher. Okay, now this is good on the left hand side. What we are also going to do is we have to check if there are any elements that are greater than the pivot. In the other case, we checked out if elements that are lesser than the pivot here. Look at this. If this element is lesser than the pivot, but there are elements which can be greater than the pivot that we have to sort on the right side. So this is the logic where we're going to say, hey, just check out if there are any elements that are greater than the pivot and make sure you keep decrementing until you find an element which is basically what? Which is basically less than the pivot element. So this is going to tell us keep going until you find elements greater than the pivot. This is going to tell us keep coming back until you find an element which is less than the pivot. That is how you know where to place the pivot correctly before splitting your array into two parts. That is the reason we've called this particular function as our partition function. This is going to give us the logic to actually partition it. Now, if you were wondering manually when we showed you the example saying, okay, so how do you know where to place the pivot element? This is how you know where to place the pivot element. And eventually we have a small logic which says, hey, if your first and the last elements have not crossed each other, just make sure to swap them, because this logic at the end of the day will ensure that your actual swapping of the element happens, but it is not the end of the story. You can just keep swapping elements all day long, but if your pivot is in its incorrect place, your entire algorithm is going to come crashing down. Ladies and gentlemen, this is a very important step. Now, whenever I've had a chance to interview hundreds of people where I've been asking them, maybe if they want to implement quicksort in the interview myself, they usually do almost the entire logic correctly, but this is the one key step that they tend to miss. And if you miss this step, it means that you're sorting everything perfectly, but except your pivot element. And if your Python program does not know where your pivot element is, then it's going to mess up. Then it's going to confuse. Your logic will basically fall. It's just like building an entire tower of Lego bricks and just pushing it down and just bringing everything crashing down, correct? So this is very, very important for you guys to understand. And eventually, what are we going to do? We want the pivot element for every single pass that we go on to do. And eventually, we are going to bring the last index for the pivot where we're going to be splitting the array into the two parts, right? So once we had to pick up the last element as our pivot element, we could do it. But once we had to split it manually, we had to make sure Python moves to the last place where it has to cut the array. So this is the logic. That's the reason we are returning the last element. We're saying, hey, wherever is the last element, pick that as the pivot, cut the array into two parts there. So this is the partition function. Now, after the partition function is where we have the quicksort function. Now, this quicksort function is very simple. All we are doing is making a quick check if we have only one element in the array or more than one element. If you have more than one element, just pass our first place index, the last place index, and our entire input array into the partition function. That is going to give you where you have to cut the array into two pieces. So after this line of code, Python will understand exactly where it has to split the two arrays. It now knows it, and eventually it will split it into two. Okay, but after splitting into two, just remember what we did in the example. We just checked if everything on the left was sorted. If not, we ran quicksort on it. We went to the right side. We just repeated the entire process. So in terms of Python, all we are trying to do is we are calling the entire algorithm on that left part of the array. We are calling the entire algorithm on the right part of the array. So this is exactly what we are doing in this simple line of code. So here we are saying, hey, just find out where the pivot element is. And from the first until the pivot, sort everything. Run the entire quicksort algorithm on that. And this is not the end of the story. This line will only sort everything to the left of it. Now, to the right of the pivot element, things are still going to be unsorted. So what I'm going to say next is, hey, just pick up the pivot element, everything, the element basically after the pivot element, and from there until the last. One to the pivot, and from the pivot to the last is our two pieces of the array, and we just call quick sort twice, one to sort on the left and eventually this line to sort everything on the right. And what this does is this is going to sort everything on the left and eventually this is going to sort everything on the right, but we have to also make sure that the pivot is sorted, and we have to just make one more check to understand if the entire array is sorted after running quick sort on the left and the right part and making sure that the pivot is in its correct place. So we call the quick sort algorithm from the first position, that is index 0, all the way to the last position, which is length of input array -1. Why -1? Python indexes from 0. So when I'm saying length of input array -1, this is going to be the 0th place, first place, second index, third index, fourth index, fifth index. But this is the 6th element. But as per Python, the index is 5. So that's the reason when our length says 6, we have to tell that, hey, it is not 6. The index is 6 minus 1, which is 5. Not 5 the exact element, but 5th index position. 0th position, first position, second position, third position, fourth position, 5th position. This is the 6th element, but in the 5th index position, right? And after that, it's pretty simple. All we have is 2 lines of code telling that it has to print the output for us, and eventually we are done. Now, this is the input that we have, 426315. Let me run this piece of code here. As soon as I run this code, you can see that our input was 426315. Our output, where we used quicksort, was 1, 2, 3, 4, 5, 6. Quicksort worked perfectly in this case. Okay, quicksort worked perfectly in that case, but what about the rest? What about another example? So let me quickly comment this, remove the comment on it. I don't have to do that, even if it is not a comment. Input, if you have watched my Python tutorial, you'll understand that the latest value, the latest assignment is what is considered, but let's just comment it just for the sake of it, because even if you don't, it'll work. Now, as soon as I hit the play button here, this becomes the input array. This is the big example that I walked you through algorithmatically, right? Now, look at this. This was our input, 1, 8, 3, 9, 4, 5, 7. As soon as you use quicksort, it becomes 1, 3, 4, 5, 7, 8, and 9. So this is sorted in the ascending order by making use of quicksort. So ladies and gentlemen, even though this looks to be very lengthy, the logic is very simple. The partition function is going to keep assigning the pivot element to split the array and make comparisons for us. The quicksort algorithm basically just calls the entire partition function on the left side of the array, on the right side of the array, and we have to also make sure that the pivot is in its correct place. Oof, that's a lot of times you have told pivot in this particular episode, as I just told you guys. So eventually you have to understand that the pivot element is literally that important. So as always, let us quickly wrap up this episode. This is the 5th out of the 5th episode in our sorting series in algorithm. And even on this one, you guys have to work on a bit of quiz questions. You can use the Jupyter notebook. The link is in the description box, as I just mentioned. Open it up, understand the logic completely. I would recommend that you can copy it if you want to at the end of the day, but I would suggest you figure out the logic on your own. Write pseudocode even if you do not know how to write Python code. Use these arrays. First, do it on paper. Take these examples, do it on paper, sort it out on paper, and once you finish doing it on paper, eventually move to Python, work on it in Python, and you guys will definitely be thorough about it. It is very important for you guys to be very thorough about this, because this is a very, very popular question to be asked in your interviews. Merge sort, quick sort, and even something like selection sort are super important, because those are the questions. The interviewer knows that in all of these steps you might miss 1 or 2 steps while you're actually doing it on paper, so they know that there are high chances of you being confused. Now that's no longer the case. You no longer will be confused, because you know exactly how to tackle an efficient algorithm, a fantastic algorithm such as quicksort, and I bet all of you all can do it at the end of the day. So I want to take this moment to wish you guys all the very best for all your upcoming interviews, because I know that you guys are going to give it everything you have, and I know you guys are going to come out shining. So ladies and gentlemen, we have completed our sorting algorithms in Python series. We checked out in the first episode bubble sort, second episode insertion sort, third episode we had selection, fourth we checked out merge sort, and in this episode we made sure to completely understand the complexity of quicksort, break it down into its most simple terms to give you this explanation. Yes, this episode is slightly longer than all the other episodes, but since quicksort is the most complex one, I had to take the time out to simplify it for you guys. So if you did like everything you saw here, do take a second to hit the subscribe button, because with your subscription I can help thousands and thousands of other other learners, students, and freshers, and ensure that they have the easiest access to really high quality content such as this. So thank you so much for watching. There are many more interesting episodes of Learn with Anirudh, so make sure you guys are stay tuned for that. And until then, I'm going to see you guys on the next one.